Hi guys, welcome to your third lecture in this series, Python logic building for CA, CFD, and data scientists, budding data scientists. Now, last time we looked at bubble sort. This time we're going to be looking at something called selection sort. But the point is, what was wrong with the bubble sort? There's nothing actually wrong with the bubble sort, but the thing is uh, sometimes we want our things to be more efficient. Then obviously, efficiency is a key. But with bubble sort, the problem was that you had to, if you remember, in case if I ask you, so just bear in mind, whenever you're talking about sorting algorithms, forget about how sorting algorithm is. You need to understand, do you know different methods to sort out one single element? Forget about the list, okay? In case if you can sort out one single element, if you know the logic behind bubble sorting, selection sorting, quick sorting, or merge sorting, then you can apply it to the whole of the list without any problem. So now, in case if I asked you to sort out one largest element, what's the end of the list? How would you do? So you'll compare this with this, yeah, this with this, 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 and like so. And the moment you find that the next value, so 420 through 423 is greater than 2, so then you are making a switch in the bubble sort, and then 423, then again you'll be making it. The moment you land on the highest value, which is actually the highest value, then you'll be start making the switches. And this is just for one element, one single element. You had to do multiple switches. We don't want so many switches to be made because switches are inefficient as far as memory is concerned, and this is okay for a list of around 7 to 8 numbers or probably 100 numbers. But just imagine, in case if we are applying the same thing and list containing million numbers, then that's not efficient at all. So now we're going to be dealing with something called selection sort. So then again, we're not going to be, for understanding purposes, we are not going to go into how whole list will be sorted. We're just going to be trying to pull out the minimum value towards the end, just one single minimum value. Okay. Process is same. Yeah. So this is the internal loop working. So whenever, let me just mark this. So this bit is for internal. Yeah. This is for this is for internal loop. And you must know that internal loop has to be carried out for n number of elements in the list, because n times, because every single element has to be sorted, correct? So this is for the internal loop. Sorry. Now for selection sort, what you're gonna do, you will say, let's assume, yeah, let's assume that the first value, let me just take this out. Let's assume this one is the minimum value. Okay, so this one is the minimum value. So if this one is the minimum value, then I'm gonna get hold of its what? It's This is underscore, by the way. It's index. Yeah. So index is 0 here. Okay. And then while we are inside the for loop, the internal loop, so we're just gonna be like, let's say for I in range, so whatever it is. So starting from here, so you're gonna be moving forward step by step, step by step, right? So the first value inside this I is gonna be 0, then I is gonna be 1, then I is gonna be 2, then I is gonna be 3, then I is gonna be 4. Why am I writing? There's a reason, you'll understand now. So minimum position, the index is 0. That's what we have assumed, right? So we are going to be checking our logic, whatever we write. So we will say if A of I, right, is greater than or equal to, depending on where you want to put your 2, right at the beginning, increasing or decreasing order, right? Then you will be checking with A of, this is square bracket, mind you, with minimum pause. Okay. Now, for first thing, AI is going to be 22, and A of minimum pause is 0, that is also 22. So that's going to be giving you false, right? Why? Because 22 and 22, they are same value, so this is not greater, right? So then you will follow your whatever the logic you have written down. So you're not going to be doing anything. In case if AI is greater than minimum pause, so you will keep on checking with I, incrementing I wherever it is. At some point, you will find a position where this is not minimum pause, right? For example, over here, 2, this is the minimum pause. So how what's going to be the I value here? 0, 1, 2, 3. So at I equals to 3, yeah, you're going to be landing at 2, right? But AI is going to be, so this value is minimum value, right? So now you're going to be saying change my min pause to what? To the index of this one, which is I. Yeah. So once you've changed that, so now your minimum position is not there anymore, right? So once you've figured out, so you are not, mind you, you're not switching anything, okay? You are just holding that value, index value in minimum pause, min pause variable, okay? So whenever you find out, once your loop is completed, and whatever is the I, yeah, so that I is going to be switched with this minimum pause. Yeah. We'll see in the program how we do it, but basically this is the selection sort is basically just making a switch once after an internal loop. But for bubble sorting, we were doing multiple switches and they were not efficient. They were not required basically. You can just hold the position of your index and then once you're out of the uh, internal loop, then you can switch over, right? Now, once you make the switch, then obviously, like, wherever is the position, so you're gonna switch that. Let's see through the code how it works, and then you'll understand better.